Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we are learned about binary tree. In this session, we will learn about binary tree traversals. Overview of the session. In this session, we see what is tree traversing and types of tree traversing. One is pre-order, second one is in-order, and third one is post-order tree traversing. Outcome of this lecture, at the end of this lecture, you all are understand tree traversing methods. So, what is binary tree? Binary tree are the data structures in which each node has at most 2 children. So, now, binary tree property is each node in the tree have at most 2 children. Okay. If there is 3 children, we do not call this tree as a binary tree. It is a tree, but it is not a binary tree. Now, coming to traversal. What is traversal? Traversal is a common operation performed on data structures. It is the process in which each and every element present in the data structure is visited, that is accessed at least once. So, traversal means accessing all the elements present in the data structure. Now, coming to term tree traversal means traversing or visiting each node of a tree. So, for example, this is the tree A, B, C, D, E, F, G. Okay. Now, tree traversing means visiting all these nodes in the tree. So, maybe it is A, B, C, D, E, F, G. Now, if you access all the elements in the tree, so that we call as a tree traversal. So, traversal means visiting or accessing all the nodes in the data structure. So, tree traversal means now visiting all the nodes present in the tree data structure. In our previous classes, we are learned about nonlinear data structures. So, consider linked list. Linked list. Now, in linked list, if you observe, we have only one path from root to last node. This is the root, this is the last node. There is a single way to traverse the linear data structure such as linked list, queues, stacks. Stack always follows last in first out. If you display the elements in stack, for example, the elements are 10, 20, 30. Now, it display the numbers 30, 20, 10 last in first out. If it is a queue, then it displays 10, 20, 30. Now, coming to linked list, here we access the elements in forward direction from root to last node. Now, if you observe in nonlinear data structures, we have only a single way to access the elements. But coming to tree, here we have different ways. Maybe we access A, B, C, D, or you access A, B, E, F, G. Means in tree data structures, we have different methods to access the elements. Now, in tree traversing, we have 3 methods. One is pre-order traversal, second one is in-order traversal, and third one is post-order traversals. So, let us see one by one. Pre-order traversal. You all are remember the word pre here. So, pre means if you consider a tree, let us assume this is the tree A, B, C. Okay. So, this is a tree. Now, pre means first display root. Okay. So, pre means first display root. Then this root have left side, left subtree and right subtree. After displaying the root, traverse to left side. After root, traverse to left side. After completion of left side, then move to right side to access the elements. Okay. So, now pre-order traversal means first we visit root, after that left, finally right. Okay. Now, in pre-order traversal, the nodes are visited in the following order: root, left, right. Here pre indicates, pre means first visit root node. So, first root node is visited, after that the left subtree is traversed recursively, and finally right subtree is recursively traversed. So, recursively means, so consider this D, E. So, first we visit A, then recursively first we display all the elements in the left subtree. After completion of left subtree, then we move to right side. Okay. As the root node is traversed before the left and right subtree, it is called as pre-order traversal. Why we call this as a pre-order traversal? Pre-order traversal. So, why means, so first we visit the root node, so we call this traversing method as a pre-order. In pre-order traversal, each node is visited before both of its subtrees. So, consider this, here the subtrees are, so B, D, E, and here C. So, before visiting these nodes, first we visit A. Okay. So, for this example, if you consider this A, B, C. Now, so first we visit A. After A, left side B. After left side, move to right side C. So, A, B, C is the accessing the elements in pre-order, is the result of visiting the tree in pre-order. So, consider this D, E. So, now, so first visit root A, then move to left side B. Now, B is the root node. So, B, then move to left side D, then move to right side E. Now, root is over, left subtree is over, then move to right side. So, it is C. If C have another two children F, G. So, now after C again we visit F, G, that is it. Okay. So, let us see the algorithm for pre-order traversal. So, this is the algorithm for pre-order traversal. So, visit the root node, after that recursively traverse the left subtree, after completion of left subtree recursively traverse the right subtree. Okay. So, now this is the code. So, let us discuss this code with an example. So, consider this A, B, C, D, E, F, G. So, let us assume, so these are the addresses of nodes. So, let us assume this is the address 100, 200, 300, 400, 500, 600, 700. Now, so what is the right of A? Right of A is 300. So, left of A is 200. So, what is the right of B? That is 500. So, left of B is 400. So, right of B is 500. So, left of B is 400. So, similarly for C, the right is 700, the left is 600. So, coming to D, so D is a leaf node. So, the right is null, left is null. Here also, right is null, left is null. For F, right is null, left is null. For G, right is null, left is null. Okay. So, now I call the function pre-order traversal with root node. In this case, what is the root? 100 is the root. Okay. So, 100 is the address of root node. Now, root not equals to null. What is the root here? 100, 100 not equals to null. True or false? Yes, it is true. So, enter into the block, print root arrow data. So, what is the root arrow data? A. So, A will be visited first. Next, again we call the same function. So, pre-order traversal route comma left. Now, again we call the same function. Now, what is the route? Route arrow left. If you observe for A, what is the route arrow left? 200. Now, in this call, the route address is 200. Again check 200 not equals to null. Yes, it is true. So, again enter into the block and print route arrow data. Now, what is the route? 200, 200 arrow data B. Next, again you call the pre-order traversal route arrow left. Now, again for B, the route arrow left is 400. Now, route value is 400. So, again check 400 not equals to null. Yes, it is true. So, enter into the block and print route arrow data. So, what is the route here? 400. So, 400 arrow data is D. Okay. So, next again we call the same function pre-order traversal route arrow left. So, route arrow left is null. Now, null not equals to null, false. Now, so previous recursive function will be terminated, and in that we have another function pre-order traversal route arrow right. Now, here in the previous call the route value is 200. Now, 200 arrow right is 500. Now, what is the route value now? The route equals to 500 now. 500 not equals to null. Yes, it is true. So, enter into the block and print route arrow data, that is 500 arrow data is E. In next call, again we call the same function pre-order traversal with route arrow right. If you observe 500 arrow right is null. Again same function is called with null. Null not equals to null, false. Now, again we move to previous call. Now, the route will be 100. If you observe, so first we visit root node, then we visit all the nodes present in the left subtree. Now, again we call pre-order traversal with route arrow right. 100 arrow right is 300. Now, the route value is 300. Again we enter into this block. 300 not equals to null. Yes, it is true. So, enter into the block and print 300 arrow data, that is C. Okay. And again we call the function pre-order traversal route arrow left. For 300 left is 600. Now, the route is 600. Again we call the function same. So, pre-order traversal. So, route is 600 now. 600 not equals to null. Yes, it is true. So, enter into the block and print the data in 600, that is F. Again we call the same function. Now, what is the route value? Now, route value becomes null. Why? So, route arrow left. For 600 the left is null. So, now null route becomes as a, now route is null and null not equals to null, false. Now, we move to, so previous function call. So, it is 300. So, 300 arrow right, that is 700. 700 not equals to null. Yes, it is true. So, print 700 arrow data G. Now, we call the same function pre-order traversal. 700 arrow left is null. Yes, now route is null. So, null not equals to null, false. Okay, that is it. Now, all the recursive functions will be terminated. If you observe, so this is the root. So, these are the elements present in the left subtree. So, these are the elements present in the right subtree. Okay, it is pre-order traversal. Now, next one is in-order traversal. In-order means, so first visit left subtree, then visit root node and finally visit right. So, for example, this is the tree A, B, C. Now, first we are going to display A or B? B. After B, A. After A, C. That is it. So, this is the in-order traversal. For this tree D, E, F, G, what is the in-order? first move to left. So, B have left. So, D, then root B, then right E. Left subtree is over. Then display root. Then again traverse to right. C, F, G. First we display left F, then root C, G. That's it. Right subtree. So, these elements are left subtree. So, these elements are in right subtree. So, this is the root. So, it is in-order traversal. In in-order traversal, the nodes are visited in the following order: left, root, right. First, left subtree of the root node is traversed. After that, the root node is traversed. And finally, right subtree is recursively traversed. As the root node is traversed between in the left and right subtree, it is named in order traversal. In order means, so first we visit left subtree, after that we visit root, then we move to right. Okay. So, let us see the algorithm. In order traversal algorithm is, so first recursively traverse to the left subtree, then visit the current node, then recursively traverse to the right subtree. So, take this as an example: A, B, C. So, what is the expected output? If we traverse in order, it displays B, A, C. So, let us assume these are the addresses 100, 200, 300. So, what is the left side of 100? 200, right side 300. For 200, left side null, right side null. For C, left side null, right side null. Okay. Let us call in order traversal with root here. So, what is the root here in this case? 100 is the root. 100 not equals to null. True or false? True. 100 not equals to null is true. So, again we call the function in order traversal. So, remember, in this function call, the root value is 100. Okay, let us write here 100. Again I call the function in order traversal, root arrow left. So, what is the root arrow left? 200. Again I call the function, now the root value is 200. This is another function call. Now, so 200 not equals to null. True or false? Yes, it is true. So, again we call the function in order traversal, root arrow left. Now, for 200, the root arrow left is null. Now, in this function call, the root is null. Now, null not equals to null, false. So, this will be terminated. Then we move to previous function, that is 200. Now, this is over. So, print root arrow data. What is the root now? 200. So, 200 arrow data B. So, B is the output. Then again we call the in order traversal with right. For 200, what is the right? Null. Again we call the function, same function with the root is null. Now, null not equals to null, false. Then again we move to same function call. Now, so this function is terminated and we move to previous call. Okay, now again, so this one is over. So, printf percentage %d root arrow data. So, now what is the root? 100. So, 100 arrow data A. So, it displays A. So, after this, again we call the same function in order traversal with root arrow right. For 100, right is 300. Okay. Now, what is the root? 300. So, 300 arrow left is null. So, now the root is null. So, null not equals to null, false. Again we move to previous call. So, root is 300. Now, print the data percentage %d. So, 300 arrow data, that is C. Now, again we call the function in order traversal with root arrow right, that is null. Null. So, null not equals to null, false. So, this is the output. Okay. Post order traversal. In post order traversal, the nodes are visited in the following order. First, we traverse to left side. After completion of left subtree, we move to right side. After completion of right subtree, then we access the elements in root node. So, consider this A, B, C, D, E, F, G. So, now, so what is post order traversal here? First we visit left side B, root is A, left side is, this is the left subtree. Now, in this left subtree we traverse to left side, so it is D, first we display D. After move to right side, that is E. Now, left and right is completed, so print root, so B. Now, this left side is completed, so move to right side, so C, F, G now. Now, in this C, F, G again move to left side, so it prints F. After F move to right side, that is G. After completion of these two, again we print the root of this F, G, that is C. Now, left is over, right is over. Then we print root. What is root? A. Okay. So, this is the post order traverser for this tree. So, first left subtree of the root node is traversed. After that, recursively traverse the right subtree, and finally the root node is traversed. As the root node is traversed after the left and right subtree, it is called post order traversal. So, post order traversal. So, pre means first, in means middle, post means last. First visit root, middle means first visit left, then visit root. Last means visit root at last, means first visit left, then right, finally root. Okay. So, let us see the algorithm. So, post order traversal. So, recursively traverse the left subtree. After completion of left subtree, we traverse to right subtree, and after completion of left and right subtree, we visit the root node. Okay. So, consider this A, B, C. So, for this post order traversal, expected output is B, C, A. So, let us assume these are the addresses 100, 200, 300. So, 100 right side 300, left side 200. So, for B, left and right are null, for C also left and right are null now. Now, so we call the function post order traversal with root. So, now what is the root now? Root equals to 100, okay, in this function call. Now, 100 not equals to null, yes, it is true, it is true. So, enter into the block and traverse to left side. So, post order traversal, root arrow left. What is the root arrow left? 200. Now, again we call the same function with the root value 200. Now, we call the function same function 200 not equals to null, true. So, again we call the function. So, post order traversal, root arrow left. Now, what is the root? Root arrow left, 200 arrow left is null, null. Now, null not equals to null, false. So, this will be terminated and we move to previous function call. Here we have another function, another instruction, root arrow right side. Now, consider right side, again same function call with root arrow right. For 200 right is null. So, root equals to null. Now, null not equals to null, false. So, this is also terminated and again move to previous function call, that is in this function call root equals to 200. So, these two are over. So, print root arrow data. What is the root now? 200. So, 200 arrow data B. Now, this instruction is also over. Then we move to previous function call. This is also over. Now, what is the root? 100. Now, the next one. So, post order traversal, root arrow right. So, 100 arrow right is 300. Now, we call the function with root equals to 300. So, 300 not equals to null, true. So, again post order traversal 300 arrow left, that is null. So, null not equals to null, false. Again the root become, then we return to previous function call, that is root equals to 300. Again we call the post order traversal root arrow right. For 300 the right is null. So null not equals to null, false. Now again move to previous call, so root equals to 300. So now print percentage d root arrow data. So what is the 300 arrow data? C, it displays C. Now so these two functions are over. Again move to previous function, now root equals to 100. And finally here printf root arrow data. What is the root? 100. 100 arrow data A. So it displays as a B, C, A. Okay. So this is about post order. Here I am taking only small example because of these recursive calls. You can take any example. Procedure is the same. So coming to summary of the session. In this session we learn about the binary tree traversing methods. So tree traversing means visiting each node of a tree, accessing all the elements present in the tree. We have three types of traversing methods. So pre-order, in-order, post-order. So pre-order means first visit root node. After this visit left subtree, elements in left subtree, and finally visit all the elements in right subtree. So coming to in-order traversal, first visit all the elements present in the left subtree, then visit root node, then move to elements in right subtree. In post order traversal, so first visit left subtree, elements in left subtree. After completion, then move to access the elements present in the right subtree, and finally visit root node. That's it. I hope you all are understand tree traversing methods. If you have any doubts, so place your doubts in the comment section. I will answer all your questions. In next class, we will discuss about binary search tree. Thank you.